Okay, I gave this a little smaller title than what was on the agenda. It's just prescribing manageability within OCP with OCP profiles. And for those who attended yesterday's meeting, the relationship between Redfish, which is we describe as many ways of managing things as possible, and specific domains. Basically, look at it and say we don't have to implement all of it. We will define some subset of Redfish that you can implement in order to manage within this domain. So for data centers, it's OCP. They've taken this Redfish interface and they've created profiles. These profiles have existed for quite a while, both as baseline and server. In the last year, there's been quite an explosion of additional profiles, and so that's what we're here to talk about today. So I'm from Intel, principal engineer. I am the steering committee rep for OCP, representing hardware management. To my right is Jeff Otter. He is a co-project lead for the hardware management project, and Mike Raineri, who's from Dell, who is part of the Redfish Forum and chairs it. So actually, both of these guys co-chair the Redfish Forum. So you've got everyone here to blame for Redfish. Okay, so what I'd like to talk about is the current profiles. I'll go into a little more detail about the profile hierarchy that we have and the additional profiles that have existed. I'll spend a little time talking about rack management profile. And then Jeff will talk about his sustainability profile, and Mike has done quite a bit of work in the power part of the profiles. So just a quick status. So the diagram on the top is actually what I'm most interested in. So we define the baseline as the common set of manageability across all OCP platforms, and then each project can extend that baseline up depending on what their platform is. So if it's a server, they have server profiles. Storage could do theirs. Networks can say, hey, we're a bunch of NICs. We need to go manage that. So what exists today is baseline and server, and the other profiles, I've been rallying them to try to write their own profile, but they say, the baseline is sufficient, and we really don't see a need to extend beyond that. We'll get around to it. So a profile is basically a JSON file. It defines the requirements for specific resources and properties. It is read by an open source validator, which will read that profile, auto-generate the test, and then point to a conformant implementation and test it. And will give you a thumbs up, thumbs down of whether it passes that particular profile. And it has been very powerful for OCP to be able to say, oh, we can have a work stream defined exactly what the requirements are, and all the back end of testing it is pretty much in place and already done. Okay? So again, OCP has this opportunity to prescribe a common set of manageability, which it has, and then manageability for components. So what we've done in the last year is if you look at the top, we've defined platform manageability at the platform level. And what has happened in the last year with the GPU manageability is they said, we could take this platform and just break it down and just do a subset. Can we do a subset for just the power subsystem, for just the GPUs, just the NICs? And so the answer is yes, but the profile itself has to become a little more complicated. So this is what we have. So what's circled in 2003 is what we have. We had a baseline, we had a server, we had rack management. And what we found is other organizations have come in and said, hey, sustainability says we're defining sustainability calculations. We want to make sure we can get those metrics from via Redfish, hence, right as the profile. We have cooling environments who decide they're going to launch an entire work stream to do hardware management for liquid cooling. They've done it in Redfish. They're in the process of closing out their profile. So not to spend too much time on this, but we'll just highlight a couple of these that we can actually go drill down into. The ones in solid black have been released, so they're posted. Within that same directory, you'll see a bunch of folders. Those are all the ones currently in draft that we're still working on. We haven't elevated it to be fully released yet, so there's still opportunities for discussion and feedback. Okay, for rack management. So the rack management, we actually, when we release a profile, we release it in two ways. We release it JSON file itself. We also release a document. And the document is which is called usage guide. It's all text, and basically I'll have an example later on, but it's far more approachable. Most people don't want to read JSON, don't want to learn it. They much rather have a document which you can comment on. And we found that profiles are far more approachable when people say, this is a use case I want. How do I do it within Redfish? Okay. So within rack management, in 2001, it was the first simple version where we have just enumerate the nodes, manage nodes that you have, give me some telemetry, some control. In version 1.1, we extended that to group operations. So when you reset a rack, you may want to reset everybody, or you may want to define some subset to reset or act upon. And so group operations allow you to take the rack, create subsets out of them, and act upon those subsets. There was also firmware update, because if you really want to go to a rack and say, update all the firmware on this thing. You figure out how to do it. You know how many systems are in it, but this is the firmware package I want implemented across the rack. And that's what the rack manager currently does, is it basically takes the package and using group operations to determine which of the subset of systems you actually want to update. So all that is great, but it's a document. And so in the background, we've actually implemented all this functionality on Golang, and is currently on open source repository within OCP. And so currently we're up to 1.1. We've snuck some of the content which we knew were in 1.2 into it already, but in 1.2 we're looking at initiative, follow-on initiative within OCP, which is the composable disaggregated infrastructure of, as we disaggregate systems across the data center, how do we compose a system that we can actually operate upon and act like a computer system? Redfish had already done a lot of work on it, so it's merely a matter of making sure that's now part of the specification. The links there are the top link is how to go find the usage guide. So it's a contribution. You just go to contribution database and look for OpenRMC. And then the second is the link to the open source implementation of this in Golang. So what's composable disaggregated infrastructure? I've kind of alluded to what that is. And so they're actually in the process of extending the rack management interface to deal with composition service and telemetry service. And at the very bottom is a session tomorrow at the Open Platform Firmware track called Exploring this Rack Management Interface for Gen AI Infrastructure. So as we've looked at this, and we see it as a central part of the open systems for AI, because they want to manage racks of AI systems, that both the implementation and the interfaces become very important to figure out, okay, if we're going to use this thing to manage open AI systems, what more does it need to go off and do? Okay, so I mentioned usage guide. So this is a general table you find in all usage guides, which is what is my use case, what are the management tasks I need to go do, and those are usually hot links, and then what are the requirements. And the hot links will take you to an interaction. It will say, if you want to get the location LED, this is the Redfish invocation you have to do within HTTP, and this is the content you will get back. See, here's your location LED. And so each one of these will allow you to hot link directly to some interaction that you need to go do. And of course, people find this far more easy to look at, because they can say, oh yes, I want that task. This is all I have to do. Is this exactly what type of data I want to come back, return to me? So this is the update to the baseline. So we've gone from power and thermal, which has been deprecated, to power subsystems and thermal subsystems, which is new and improved. And we've added use cases, and we now do not require the support of HTTP. That HTTPS is sufficient, because again, users have come back to us and said, you know, in my system, I don't allow HTTP at all. Don't even put it in your set of requirements. So we've done that. So with that, I will hand this to Jeff, who will talk about his sustainability profile.
Wait, I'm going to have that because I have one slide. Yeah, so as we talked about in the intro, one of the key elements of the hardware management project is to reach out to all the other OCP projects and help them integrate and have consistency in the way that all of those different types of devices are managed. So the sustainability track and that work, the collection of work streams under that top-level program or project is new for OCP. So I've been working with those folks, and they're actually in the next room, so I have to run over there and give the same talk with a little more detail. But the sustainability folks needed the telemetry and effectively just the data to be able to measure the sustainability pieces, which for most of our IT gear, it falls into two categories of either the embodied carbon, the carbon cost to produce the product, and then what's called the use phase, which is really the energy consumption over the life of the use of the product. And for all of our stuff, since they're all based on AC power plugs, about roughly 80+% of the carbon emissions comes from the energy produced or the energy consumed during its lifespan. So if you're going to do something about that, first thing is you got to be able to measure it, because you can't tell if you're doing better or worse, or how you're comparing to your peers if you can't measure it. So since we had already plumbed all this in systems management to expose the power and energy measurements, we wrote a profile that says, well, Mr. Product Person, if you want to meet the sustainability goals of OCP, then you need to be able to provide this kind of data, and here's how you do it. So we wrote a profile that lists out those requirements, and now the sustainability project, we're going to get them to say, please go to all the other hardware groups and please tell them that they need to conform to that profile. So the sustainability profile covers three areas. The first is kind of straightforward from our perspective, but it's really important for sustainability, and that is you got to have good product identification, because figuring out what is in the platform and to be able to do all the carbon accounting, you got to know what's there. So just being able to do basic make, model, and serial number or model number stuff is critical for that. So because that'll all be done through database lookups, because you can't sniff the carbon content with the product, at least not with today's technology. So that's the first area, pretty straightforward. I hope nobody has a problem meeting those goals from the profile. The second is really the biggest piece, and that's the energy and power measurements. And so the profile is starting with just the basics. I want total power, total energy consumption, basically what's coming out of the wall and being consumed. As we have another work stream in sustainability to talk about power efficiency metrics, we'll be defining more details here so that you can drill into what subsystems are consuming power, and then look at things like what is your idle power versus your actual workload dependent consumption. And so trying to dive into those things, separate things like fan power, which is considered a waste. It's not productive in terms of compute. So they're going to try to drive efficiencies by separating those pieces out. But again, until you can measure it, you can't tell how good or bad you're doing. So that will be ongoing. But the energy and power measurement is the biggest ask from the profile. And the last bit is the physical location, because again, a lot of the accounting of this is going to be based on your location, because that's the shortcut for getting the carbon coefficients for the energy consumption. And obviously, depending on where you are in the world, cleaner, dirtier energy production, that's a big factor in the accounting. So having a way to extract from the product, where am I in the world? And that was using some recent additions to Redfish that revamped the way that we do report all effectively the physical addressing. So hopefully that's now an easier way to do that, and it matches a lot more of the modern ways that people use map APIs. So it should be easier to implement and easier to use. So, but that's the content of that. And like I said, if you need to learn more about that after these sessions today, there are sustainability track pieces right next door that will go into more details. And I'll pass it on to Mike to talk about, well, power.
Thanks, Jeff. So as we indicated earlier, we're kind of exploding our usage of profiles, and so one of the new additions is to define a rack PDU profile. Oh, did that? No. Yeah. So what you'll find today is that the proposed rack PDU profile is really just a conversion of existing functionality that you might find in a rack PDU, but converting into Redfish. So today, rack PDUs might have a web UI. They support SNMP, but this is to help transition them over to Redfish. Primarily showing how do you get your through information about the rack PDU. So all the part number, serial number information, how do you get the unit metrics out of the system, like what is the current operating temperature of the rack PDU. There's also subcomponents involved, so showing all the different outlets, all the different circuits, inputs, getting all the, showing all the metrics associated with them. Also creating requirements for reporting all the electrical statistics, so all the voltage readings, current readings, power readings, energy consumption, and divvying that up across all the different subcomponents so you can get kind of breakdowns of the different subsystems in your rack PDU while still being able to understand what is going on in it. And then just overall general actions available on existing rack PDUs, so remote power control of outlets. That's a common thing you'll find in a web UI. I need to go power cycle an outlet, so there's a Redfish equivalent to do so. There's also the power shelf profile. So kind of same vein as the rack PDU profile, trying to baseline current existing power shelf products and map existing functionality over to Redfish. So very similar methodology, being able to have requirements to show consistently all your through information, being able to show the status and health of all the components. So the unique thing with power shelves is they have individual power supplies. So those are their own throughs, they have their own part number, serial number, they have their own health, their own metrics, their own monitoring, reporting all of the internal types of electrical connectivity and statistics, so showing all the different power readings, energy readings, voltage readings, current readings, and then likewise all the power control for the output branch circuits. All right, you want to take this?
Okay, so that's a quick survey of the profiles that exist. One thing you'll notice is that we don't do everything within the profile workstream. It's kind of a collection mechanism to get these things moving along, but we work very closely with the other projects within OCP, both with sustainability project, with cooling environments to do the entire liquid cooling. As I mentioned before, they create an entire track to go deal with manageability. With power, we'll be working with Rack and Power project to make sure that this aligns with the stuff that they want done and take whatever feedback we have. So we try to reach out to all the subject matter experts, and they're not necessarily in the work stream. We understand profiles. We understand how to encapsulate profiles and requirements to make sure that they're accessible via Redfish, but we require the subject matter experts to tell us where we should go with this. GPU, basically we know nothing about GPUs. So we'll let the GPU workstream go have their way with it for a while to figure out, very broadly what the manageability is. But from the GPU profile, we can see a component level profile, which is basically what is the commonality that all components need to have, not just GPUs. And so that will become a component baseline from which the GPU profile might spawn from. So getting this commonality, whether it be a common baseline for platforms or common baselines for components, the goal is increase the interoperability, make them look more common. So both from the Redfish implementation, you don't have to implement a bunch of various code for various things. And from a client standpoint, they all kind of look the same, guys, and from a manageability standpoint. So call to action is join profile workstream if you want to get this stuff moving. We have pull requests. So we have, as I mentioned, most of the profiles, whether they're released or in draft, they're out there, which means you can pull them today and run them. And we have people who've done that and said, you know, your server 1.1 profile isn't quite there yet. Yeah, I ran it and here are my issues. We can fix that within the pull request before we do the actual merge. So we find that very, very productive. Let's see, test conformance, profiles and submit issues, and then update design specifications. So all these profiles are great, but if I don't get a design specification from server that points to server 1.1 profile, because currently it points to server 1.0, right? If I can't go into the server project and say, we have a better profile for you to point as your baseline, then this thing has no teeth, because it's the server design spec which you have to follow in order to contribute server designs into OCP. So that's the only way we're going to move stuff from draft into full release is if we can convince the sustainability project to go add a line somewhere in the design spec to say thou shalt conform to the sustainability profile, and same with rack and power. So if these things reside in draft a long time, that's why we need some pressure applied to these other projects to say, yes, we need a better one. Okay? Hey, I was trying to meet up time again. And
Maybe one quick question.
Yeah, can you relate the profile management, security management in particular, how to establish a secure boot environment, a remote attestability environment, and secure remote update environments?
you could try, yeah.
So all of those types of features are part of Redfish. So what we would need from that is create a security profile to say, I have these. You need to implement your secure boot database. You need to be able to manage the keys. You need to implement the component integrity resource if you want to remote attestation. So we don't have that right now in our profiles, but if that's a requirement and we need, then it sounds like it's time to draft a security profile.
All right, let's thank our speakers. Thank you. Our next